Right, welcome everyone. It's great to see so many people here joining our webinar on how to run a challenge. This is organized by the MICCAI Special Interest Group for Challenges, for which we have two representatives here. It's on the one hand, Ping-Hoon, who is organizing the webinar series, myself as the secretary, and Bram and Jake are both also in our special interest group, representing the grandchallenge.org platform and Sage Networks, which we will hear about today in our great talk. So let's directly jump into it. We will first hear about grandchallenge.org, and I will hand over to Bram.
Thanks a lot. Can you see the screen?
Yes.
Okay, perfect. So thank you very much for this opportunity to present grandchallenge.org and discuss how to run a challenge on our platform. I have with me Kiran Venkatesh and Anindo Saha, and each of us will present a part here. I will start with a general vision why we developed Grand Challenge. Then Kiran will show a couple of details on how to run your own challenge on the platform. And Anindo will talk about Bikai challenge, which is currently running on our platform, to give you a bit of a hands-on view on how you set up a challenge on grandchallenge.org. But first, what is the platform? The platform was originally intended for challenges. We have over 74,000 users that have been registered on the platform. Hundreds of challenges have been running and are still running on the platform. And it's now also possible, and this is really the development from the last couple of years, to link challenges with algorithms. So you can now organize challenges where participants actually upload algorithms that then participate in the challenges, but are also available for all the other users to apply their own data to. So what was the reason for us to develop this? Well, this is a typical problem. We are all researchers and we develop algorithms and we publish about that. And for example, a researcher publishes a segmentation algorithm and would then show in his paper some results on locally collected test cases, and maybe even compare in the paper the dice score that the researcher obtains with that is reported in other papers. But yeah, these results in other papers have been obtained on other data, so these numbers are not really comparable. How do you solve that issue? Well, you organize a challenge where you basically invite researchers from all over the world who have an algorithm for that same task to participate, and then compare all algorithms on the same test data, providing a fair comparison. And that is what we did at MICCAI in 2007 for the first time with segmentation of the liver and the caudate. And we later then ported the sliver challenge to Grand Challenge. And now in 2022, you can still submit your results for this challenge and get a line on the leaderboard. What's more, you do not only get a fair comparison, but if you would write an overview paper, this paper can be seen as kind of a review paper summarizing the state of the art in a particular field. For example, in this case, liver segmentation. And what we saw then, that when this was possible and challenges were actually implemented like this, that there's still the issue that organizing and running it is a lot of work. And these challenge websites typically became dysfunctional after a couple of years, typically when the PhD student who had originally set up the challenge had a new job, and yeah, the website died. So that's why we implemented functionality on grandchallenge.org so that people organizing a challenge can upload the code that needs to run when a participant uploads results, where some metrics are computed and ultimately there's a line on the leaderboard. That code you can upload in the form of a container, and then basically the challenge can run forever. So here you see that for Lola 11. And in this way, challenges can continue. The documentation on Grand Challenge, there you can read how to do this, how to build your own container containing this code. And we now actually ask everybody who uses Grand Challenge to commit to support the challenge for up to 5 years, because this is possible now with this technology. And it basically means that you have to be available for some questions. All the challenges on Grand Challenge have a forum integrated. So that's basically what we ask people who run a challenge on Grand Challenge to maintain. But there are more issues. The challenge could be a huge success, and the leaderboard could contain great solutions to a particular problem. And what you will see is that researchers, even clinicians, will approach the challenge organizers and asking, okay, can I use these great pieces of software that were so successful in the challenge? And I had that question many times, and then I always had to say, well, no, I can't give you the code because I'm just a challenge organizer. You need to contact the teams who participated, who sometimes do not answer or provide code that people cannot get to work. So we thought we need to solve this. Otherwise, the results of the challenges still do not result in reusable software. Now we've added that to Grand Challenge in what we call type 2 challenges, where participants do not upload the results on the test data, but instead they upload the algorithm that they have developed in the form of a container. So this algorithm is then directly available on the platform. Here you see the leaderboard of STOIC 2021, the challenge where we had the closing webinar about last week, where you can see the algorithms that have been submitted, and some of them have this GitHub logo behind it. You can even directly click on that and you go to GitHub where the code is. And everybody who is registered on Grand Challenge can request access to all of these algorithms that have been submitted for each of the challenges. And this is, for example, one of the top algorithms in the STOIC challenge, which is now available for everybody on our platform to upload your own data to and download the results of. And there are additional advantages to these type 2 challenges. For example, sometimes you have test data that you're not allowed to share because it's maybe from a clinical trial or something. And by organizing a type 2 challenge, you don't need to share your test data. We've also seen in some challenges that some participants actually cheat, for example, by letting a radiologist look at the test data and correct the output of their algorithms before uploading. Well, this kind of cheating is not possible with a type 2 challenge. But you could take it a step further. Sometimes it's also not possible to share training data, or the training data for a challenge is so large that it would not be practical for participants to download the training data and train their own systems on a single GPU. And that goes towards type 3 challenges, which we are testing out now on Grand Challenge. It's not publicly available yet, but here the idea is that participants upload a container with an algorithm that can train on secret training code. And this training output is then an algorithm that participates in a challenge. So it's summarized in this table on the documentation. So in type 3 challenges, both the training data, the test data, and the test labels are closed, and the participants upload a training algorithm. And we expect to see more of those challenges in the future. Now, we've also set up a partnership with the Middle Conference, where there is now a call for challenges. So people who want to organize challenges with Middle, they get certain advantages if they run their challenge with Middle. So if you're interested, please go to the Middle website and read the call for challenges. And now I'm going to hand over to Kieran, who will show a bit more about how to run your challenge on Grand Challenge.
So over the next few minutes, I will show you the nuts and bolts of Grand Challenge and how you can use the platform to optimally set up the challenge. First and foremost, Grand Challenge provides a wiki with which you can create a site, add and edit pages. This can be pretty helpful for PhD students like me. For example, we may not have sufficient web development experiences to set up your own challenge. So you can use the platform to set up the website and put in all the information that's necessary for running your challenge. And with a user base of over 74,000, Grand Challenge also has sophisticated user management features wherein you can request participants to request for your challenge, and then you can review these requests and you can allow participants to form teams. And there's also a forum where you can address questions which the participants may have for your challenge. And Grand Challenge also produces secure ways to host challenge data. And this is pretty useful for type 2 challenges where your test set has to be hidden as a private archive. And how you would do that in Grand Challenges, you go to this website, grandchallenge.org/archives, and you may have an option to create a new archive wherein you will put your input data, which is part of your hidden test set. And you should be careful to not upload your labels in this archive because you do not want the participating algorithms to access the ground truth images, which would defeat the purpose of the hidden test set. And if you look at the website for the archives, and here in this screenshot, I have selected a subset of the archives which belong to MR images, and the results show a few archives which are part of the hidden test set of the Bikai challenge. And you can see that in all these cards, there is this lock symbol, which indicates that these are private archives. And unfortunately, since I'm not part of the organizing committee, I do not have access to these archives, so I cannot show you what is inside this. However, I can show you the details of a private archive, which was used as part of an educational challenge within Radboud University. Now, if you look at this page, this archive contains several panels on the left. There's a panel for information where you can provide generic information to your co-organizers as to what this archive contains. And there's also this editors page where you can add your co-organizers to give access to the dataset, where they can add cases or remove cases if certain cases do not match the quality of necessary to run a challenge. And you can also add users where you can invite users to review your data, but they may not have permissions to add or remove cases. And you can also view images where we have an integrated web viewer. For example, in this image, we have a lung nodule, which can be viewed on 3 views. And also you can scroll through the slices of this CT image to inspect the nodule. Apart from the ability to host the challenge data, Grand Challenge also provides secure mechanisms to hold your algorithms, which are important for running type 2 challenges. And if you look at the algorithms page, we have several highlighted algorithms here. And you also have this button where you can, if you are a verified user on Grand Challenge, you will have the option to add a new algorithm. And again, I may not have permissions to access all these algorithms, but I can show you what an algorithm page would look like. Again, this is the baseline solution which was used for the internal educational challenge. And similar to the archive page, we have several panels here with user management pages. But one of the most important panels that I want to show you here is the containers page, where you have the ability to upload Docker containers for your algorithm. But recently, Grand Challenge also introduced a new feature wherein you do not have to upload a Docker container directly, but you can link a GitHub repository which contains the code that runs your algorithm, and Grand Challenge will automatically build a Docker container for you. This is pretty helpful, especially if you're not familiar or comfortable working with a local installation of Docker in your laptop. Once your algorithm is ready and active on Grand Challenge, then you can proceed forward to submitting the solution to a challenge which accepts algorithm submissions. You would just simply click the submit button, go to the appropriate phase, and previously in place of having a drop-down menu where you upload the predictions file, you will have a drop-down menu which lists the algorithms that you have access to, and you can go forward to submit that as a solution to this challenge. Now that we have covered setting up the data and the algorithms, we will now move forward to automated evaluation. In order to use the automated evaluation feature of Grand Challenge, you have to make sure that you containerize your evaluation scripts. And to make this process easier, we also have an open source package called evalutils, which allows you to build the repository to build a Docker container. But some of the major principles that you have to follow is that you have to package the ground truth in your evaluation container, and you have to write your container in a manner that it reads the predictions from /input and writes the metrics to /output as a metrics.json file. And then you can just go forward to your challenge page. You click on admin, you go to the methods in the bottom left, and then you just click on this add a new method, and you can upload your evaluation container, and then it becomes active on Grand Challenge. And on top of this, you can also click the hyperlinks for each of these methods and then investigate the submissions and evaluations that have been processed by this evaluation method. And this is pretty helpful for participants who submit solutions to type 2 challenges, because they may not have access to the hidden test set, and only you as a challenge organizer will have access to the hidden test set and also the logs of these submissions. And you can read these logs and then guide participants to help them debug their solutions. You can also throttle submissions. For example, if you click on the submission tab for the evaluation settings, then in this example, we have limited the participants to a maximum of 10 submissions per phase. And this is very helpful if you want to prevent participants from overfitting to a small test set. And you can also request participants to upload a supplementary file. In this case, it could be an archive article, which can appear on the leaderboard as a line. And the next step is to connect the evaluation metrics to the leaderboard to use the automated leaderboard management mechanisms in Grand Challenge. And you would do this by linking the key from your metrics.json file and add this as a JSON path in the scoring tab of the evaluation settings. This is pretty straightforward to do. And if you want to know more details, then I would urge that you check the documentation. But the procedure is pretty straightforward. You just have to add the key in the scoring tab. And then automatically Grand Challenge sorts the leaderboard based on the metric that you're linked. And for example, in Stoic Challenge, all the solutions to the leaderboard are ranked by the AUC severity metric. On top of this, Grand Challenge also produces or provides mechanisms to support multiple phases. If you have multiple tasks, then you can create an evaluation container for that specific task, and you can basically replicate the process. For example, in Stoic Challenge, there was a qualification phase, which probably had a small number of cases, and the last submission phase, which probably had a bit more cases. So you can simply replicate the process for each of the phase that you may want in your challenge. Finally, we also have a REST API with which you can programmatically interact with the features of Grand Challenge, for example, the archives and algorithms. And here again, we have one of the top solutions of the recently concluded Stoic Challenge, as Bram previously mentioned. And you can simply use GC API, which is again an open source library that's part of Grand Challenge. With just 3 lines of code, you can interact with the best performing solutions of your challenge and obtain results. And if you go to the results page, you will see the result of that particular image that you uploaded. And you click on the result in viewer, and it also produces the output of your image, and also has the ability to inspect the image on Grand Challenge. So with that, I would conclude my part of the talk and hand it over to Anindo, who will take you through Bikai Challenge.
Thanks, Kiran. So I'll just go through the Bikai challenge quite briefly at a higher level to just give you an overview of such an example challenge. So this is Bikai, and I have the tabs open so it's easier. So the way we organized the Bikai challenge, at least on Grand Challenge, the site, is we really wanted that you could see the entire story of Bikai through the website itself, every aspect, how it was conceived, everything. So when we were first formulating or conceiving this challenge, the first question we asked ourselves is, do we deeply understand the clinical problem? What is the present day role of radiologist and MRI when it comes to prostate cancer management? Because that is what we tackle in Bikai. And we want to know what is the counterpart in present day life? How does it play into the guidelines that we have in clinical practice? And what should be the specific task we should try to model with AI for this challenge? So in radiology, prostate cancer lesion detection in MRI works like a detection problem. So you have different lesions that are identified and assigned a PIRAT score for severity or risk assessment. And so we did the same for the AI challenge. Next, Bikai, of course, would not exist in a vacuum. We need to look at the precedent for this challenge. So were there any previous challenges for this? Are there any public data sets available? What can we learn from them? What can we improve upon? So the main other challenge in this space was the Prostate X challenge. And the main limitations there were a small testing set, only 140 exams. And the other thing was the type 1 challenge format, which is publicly available testing images as opposed to truly unseen cases. And this kind of limited our ability to draw definitive conclusions. So now that we know what we want to work towards, what we did was partner up with the right centers and the right technical societies so that we could scale up together and overcome these shortcomings in a meaningful manner. So a direct result of this is, if we go to our datasets page, is that we were able to release 1,500 cases, multi-center, multi-vendor, for this challenge publicly. We also were able to reserve a pool of 1,000 cases for testing amongst a few other subsets. And in the interest of open science and transparency, we released all characteristics about this data set, the imaging data, the things and disclaimers you should be aware of, additional content and publications. If you want to dive deeper into MRI for prostate, what it really means, what you're looking in these images, scanner information, registration, the annotation workflow that we followed, along with the reference standard. So what constitutes as a positive, what constitutes as a negative? We want it to be completely transparent so that this data set is usable through the future, not just for this challenge. And then the next thing we did was
drag that away.
Oh, right, perfect, thanks. So then we modeled the task for AI, right? So this is the task, it's lesion detection. So given a scan, we would then produce a detection map. We would then have an average precision score from the precision recall curve. And from the detection map, we can have an overall likelihood for cancer. And that gives us an AUC metric from the ROC curve. So these metrics, for instance, were debated long and hard. And we've finally come to these two conclusions. And what helped us kind of come to this were, for instance, guideline papers from MICCAI's bias initiative, which talk about common metrics and validation strategies. We looked at those, and we looked at what other clinicians recommended in the past as well. So we've released baseline state-of-the-art solutions using the NNUNet, MONAI's standard UNet, and then detection in GitHub open source code libraries, as well as the same for the evaluation metrics, and as well as the statistical tests we plan to apply at the end of this study. So once we had an overall idea, this is the task, this is the data set, this is what we wanted to do, we realized that we might not necessarily be the only ones who think we know best about this field. There are many other expert centers around the world who know a lot about this. So we wanted to reach out and inform our opinion, which is where the scientific advisory board comes in. So we reached out to many experts in AI, in radiology, as well as urology to get a really multidisciplinary perspective on this problem. How should it be tackled with AI and how should it be validated? And our findings from this whole overall study design, as well as the changes we made from our discussions, was included in the structured challenge submissions form that we have here on Zenodo, as well as pre-registration. So yeah, with this, our challenge was ready and we went live around May. So in the first month, as Kiran talked about the forum, I think this was really useful for us in particular. As you can see, we have many threads that were opened by participants that were announced by us, along with one for the data set. So what this allowed us to really do was engage the community. And by leveraging the collective expertise and knowledge of the community, we were able to spot bugs in the data, in our code, and hammer these out in the first month. So this was really useful for us to engage with them. And this is still an engaging space for us to really talk about how this task could be tackled through the future. And after that stage was done, soon after, we started seeing submissions to the leaderboard. So the first part of Bikai is modeled as a type 2 challenge, meaning you upload AI algorithms rather than predictions for the testing cases or validation cases. And so far, we have a little over 100 submissions. All of these are AI algorithm containers that were validated completely independently, so they couldn't see the testing images.
You can see their ranking score here, as well as this is currently engaged. But if you deactivate it or activate it, you can see additional metrics that you as an organizer can set here. If we go even deeper, we can even have frog curves connected here where you see the full evaluation. But in this context, I'll just keep it till here. So our baseline algorithms for this challenge, as you can see, also has this GitHub icon. And as Kiran indicated before, if you click on this, you can see the exact source code and the exact container that was produced to make that submission. And that makes it a lot more reproducible and easy to engage. So with that, yep, I'd like to conclude. And this is the Bikai challenge, and it's still live right now. And yeah, hope you liked it. So I'd return the floor back to the moderator. Thanks.
Thank you very much for this very nice and interesting presentation about Grand Challenge and all the opportunities that you have there, which is really great. Before we go to the questions, we continue with our next talk about Synapse and Sage Bionetworks, and we will have a Q&A at the end. So Jake, the stage is yours.
Yes, thank you. So I'm Jacob Albrecht. I'm Director of Challenges and Benchmarking at Sage Bionetworks. And for this presentation, I wanted to, I prepared something a little more high level and perhaps more philosophical about how we go about organizing challenges through Sage. So we are open science nonprofit based in Seattle, and we support a variety of different initiatives and data coordinating centers and other research projects. So not necessarily medical imaging, but it could be other types of genomic or electronic health record types of data sets. And so we get lots of queries from different potential partners about options for running a challenge. I just wanted to start with a quiz for the group. So thinking about why should you organize a challenge? So what should be your motivating factors? So it could be to identify novel methods or analysis approaches for different types of data sets. It could be to analyze novel data. Typically, teams can come to us with a new idea or some new data that they've collected or plan to collect, and they want to promote that data set by hosting a challenge. The third option is to further expand that concept and build more community around an event. So hosting an event to raise awareness about a particular research topic. Or option D is to provide an opportunity for learning. So helping students test out different methods and really play around with different types of real world data for their data sets. And so on this quiz, the right answer is, of course, all of the above, where challenges give us the opportunity to try all of these different drivers simultaneously. And it's a great way to advance the state of the art for novel methods applied to novel data, but also building community and providing an opportunity for newcomers to the field to learn some of approaches. But organizing a challenge can be difficult. I think Bram did a great job of describing the some of the effort and pitfalls that can be associated with creating a challenge. And while the infrastructure is a very important part of organizing a challenge, what we find a lot of planning has to go into before you provision that challenge project. There's a lot of preparation that and lots of risks associated with the data set that you're working with, the questions that you want to ask of the data, the types of metrics that you want to employ, the ability to attract and engage a pool of participants to your challenge. and then building out the identifying and building out the appropriate infrastructure, and importantly, conducting a post-challenge analysis. So we have various ideas that are pitched to Sage and dream challenges. Not all of them are have a high likelihood of being successful challenges. So we do tend to identify some gaps in the methodologies or the current state of the data to help keep the challenge experience as productive as possible. So at the same time, we can see an increasing number of challenges in the field, and so this is great to see that more domains are adding challenges as the years go on. It's with better computing infrastructure and especially technologies like containerization. It's easier to collect and evaluate different types of challenges, and so this can mean more effort. It's more participants and more effort, and so there's a greater awareness in the community of the value of challenges, which is great to see. I see it still as a greenfield opportunity. There's many more opportunities for challenges, and it can have a much bigger role than it currently plays. So it's great to see organizations, especially MICCAI, really take a lead in using challenges as part of how they evaluate methods and bringing a community together around it. And the converse of that is that if you set up and run a challenge, especially for first-time participants, if it's very difficult for them to get engaged and to get a scored submission, if they see problems with the data that don't get addressed, or if they think other teams are cheating or have some other unfair advantage, it can undermine their interest in participating in future challenges, and so that hurts the whole field of data-based challenges. And you can see on this this timeline, many groups have started to add challenges over time, and groups like MICCAI have added many challenges over increasing over the years. I support through Sage a lot of these dream challenges here on the last line, where we've been running challenges since 2007. And in that time, Dream has put together an overall process, reviewing the steps that go into what makes a challenge successful. And these are general purpose types of challenges where we're thinking in abstract terms of the types of data and questions that can be asked. But we've seen that they follow along a few clear steps that are important. It involves a lot of details around the scientific, technical, legal, and social requirements. This process we rely on to make sure that we check all the boxes, so to speak, in getting started with our challenges, starting with a scientific question, and then building a team and getting the right people involved to build out that question, collecting data with the appropriate approvals and DUAs, testing out different methods with a dry run, provisioning the appropriate IT and web infrastructure, aligning incentives for the challenge. It's an important driver of getting engagement on an activity, and then advertising and communicating the challenge itself. And then once this is more than half of the process, and then you can start to launch the challenge and accept submissions. So you have to create challenge rules. You have to make sure that you have a user agreement with the participants that they can sign off on, and this is approved by our governance group at Sage. The scoring and analysis takes place continuously through the leaderboard, and then after the close of final submissions, we typically do a final analysis of the competitive phase of a challenge, and then move on to what we call a collaboration phase, where we, because it is a scientifically focused organization, we work on the publication is the primary output of a challenge. The Synapse is where we run our challenges is built to be a long-term data repository. So challenges and the data itself can exist in Synapse indefinitely. And we see often that we years after a challenge is over, people will request the data. They'll be doing a research project involving some of the challenge data. And so it is very important to think about the life your challenge will have after the top performers have been announced. And so keeping those challenges in a database so that they can be accessed and revisited in the future is very important. So from our user research, we found there's a few drivers of a challenge. So for organizers, we it's perhaps overly simple, but we describe it as three things we need to run a challenge when we're first approached. So thinking of the data quality, so high quality data that is cleaned and ready for analysis. Original data is best to avoid data leaks or cheating by looking through public data sets. And then an important and meaningful scientific question, something that would be an important contribution to the scientific literature, is also a requirement for the tasks and subtasks that we have for a challenge. And then finally, funding. So funds for preparing the challenge, money to collect the data that you need to collect for the final evaluation. But we need to provision data scientists' time if you to compensate those who are preparing your data. It could be graduate students or could be other professionals. Then including the computing and prize incentives are also costs that factor into a challenge. And then when we talk to participants and organizers about how the people have participated in their challenges, we find four main drivers for participation. So for when we open up a challenge to the public domain word, if it is advertised successfully, we find participants from all career stages and backgrounds. Participants come from all around the world. Every continent except for Antarctica is represented in our challenges, and all career stages. And so these can be graduate students. We've seen teams of high school students participate in challenges. We see other citizen scientists, people from outside who have maybe a completely different educational background, but they have an interest in programming and in science. And so they'll submit to a challenge. The value of data is also important, not only for organizing a good challenge, but it's also an attractor. It brings in challenge participants to have an opportunity to work on a new data set that is something that they haven't seen before, that they could have new insights and scientific potential for them to analyze. And then personal growth is also a big driver for what brings people to our challenges. The ability to learn a new technique, try their skills test their abilities to create a model. You can only go so far with your tutorials and example models. And I think from personal experience, you tend to learn a lot more when you try to analyze a set of real data and you get disappointing or mediocre results. And that really prompts more appreciation of the hidden traits of good data science to really maximize the value of data and build the best possible model. And then finally, trust. So knowing for participants to know that they can get support if they need, that they can work with the challenge organizers to debug an issue or to call out problems in the data or a choice of metric, and to get that feedback and justification and extra background information. That's incredibly important for these types of real scientific challenges, is understanding how the data is collected and other factors that could go into feature engineering. And so when you create your challenge, you need to collect a minimal amount of information. So we have an intake form that gathers information. So this is just simple information. We have a high level data collection process. So just a name and summary, some links to other organizations, information about the challenge itself, the objectives, who's sponsoring and organizing the challenge, crucially the year. If you create a challenge, what year you created it, but 5 or 10 years down the line, it's important to have that historical context. It's always good also to track the number of participants, and then describing the data, especially some of the governance and setting conditions for post-challenge access. We typically include an embargo period on publishing the results of the challenge, just to give us time to create the landmark paper to describe the data set and challenge. And then at that time, all the participants are free to publish on their own methods. And it's important to really document the task in high detail, having the description, the timelines, and therefore the status of the challenges, thinking of the incentives and how those tasks will be evaluated, crucially for cases like ties or other situations that can arise when you're evaluating submissions. And then thinking about the publication and getting started as soon as possible. Many journals now will consider a challenge as a good use case for registered reports. So if you're able to start your challenge even earlier, you can register it with a publisher, and then it's set up and ready to publish very shortly after your challenge and analysis is completed. We collect the top performers and invite them to contribute to the manuscript. And they can pool submissions and look at ensembling methods to really drive the scientific collaboration around a goal. So what we see is different orthogonal approaches coming together can create more powerful models than any single team could submit on their own. And I also want to promote the bias reporting standard for biomedical image analysis challenges. And so this was something that's been spearheaded by MICCAI. I think MICCAI as an organization is very far ahead and a thought leader in thinking about what makes it for a good challenge and how to set standards in a way that challenges have the most value to the research community. And also thinking about what organizers should provide. So just the basics, really, considering the annotations. This is called the ground truth, or sometimes gold standard, for both the training and model validation. You have to ensure that the metrics are appropriate and they can discriminate between submissions. So you want well over 100 instances for predictions. If you have 100 participants, you really want to minimize the number of ties and provide a lot of gradation between the possible submissions. If you're doing a classification task, for example, you want to collect class probabilities and not the class outcomes. So an AUC over an F1 type of score. You want to provide for your participants details on the evaluation infrastructure, specifically what type of GPU or computing resources are used for the evaluation, because that can make a difference for how they would prepare and train a model. Providing participants with a starter kit or a reference method is very critical, giving them code that runs that would create a valid submission on the challenge that they can then take and further tweak and add modifications is really important to ensure that people don't get frustrated initially. If they're able to make that first submission, they'll likely stick with the challenge and make more. And of course, you need incentives. So thinking of money, or this could be a cash prize. It could be very often we see travel budgets to present at a conference. I think that's more common. Publication credit, it's something it's easy to include. It doesn't really cost anything. And then in conference presentations, the incentive is also this access to new data that we see that drives new participants in, and then thinking of any other value that you can provide, promoting the winners through your communication network, introductions to your scientific board. We see that for nonprofits who don't have money but have influential connections. They can offer a introduction with like pharmaceutical companies or other valuable partners. And then it's also important for organizers to provide support through a discussion forum, anticipating frequently asked questions about how do I create a Docker model, and also being present for judging submissions write-ups. So we include write-ups as part of the process. It's good to have that way into the evaluation process. So what we so we want them to take part in that, to add some soft a qualitative evaluation of methods. So the overall timeline that we typically use, we have a long pre-launch period where we're setting up the questions and working with the organizers on these challenges. We hosted the challenge through Synapse on a Synapse wiki. And then we have a pre-registration phase open, so participants can join a pre-registration mailing list, and then they get announcements when the challenge is launched. Once we launch, we have typically 3 phases where there's intermediate rounds, and then a final submission validation round, and then we take all these submitted methods and then evaluate them again on withheld methods. We allow for either a single prediction file submissions, or a containerized model, and like brand challenges, we much prefer having the what we call a model to data, or that type 2 challenge where you have the method in hand, you can evaluate on new types of data. Although the participants retain the license for their method, and as part of the rules and agreements, they grant the dream organizers an open access license to use it for the purposes of the challenge, but the IP remains theirs. And then after that phase is done, we launch into a community phase where we draft the analysis. So some common problems that we encountered during that submission phase is problems with data quality will appear there. You can be sure that if there's a problem with the data, it gets found by many eyes exploring the data set. So different problems related to class imbalances, noisy or missing data, information leaks through a leaderboard. That's something that's always a concern. I'm not aware of any instances where it was an important problem for a challenge, but you want to prevent that as much as possible, and with limited challenge submissions and releasing as minimal amount of information as you can for each submission. We want to provide support to participants and discourage cheating, for example, through creating multiple coordinated accounts, and so monitoring those submissions to look for suspicious trends. You need to make sure your infrastructure for evaluation is correct. So I have here a plot of cumulative submissions over time for a real challenge that closed, where you can see there's a long delay and then a steady rate of challenge submissions. And then in the last week of the challenges, you see this exponential spike in submissions. And so your infrastructure should be able to handle that, or at least rely on a queue to work through that final crush of submissions from the participants. Other problems related on rules for publication need to be very clear about when the participants can publish their methods and follow up on that. And then other small details about organizing a challenge, making sure your deadlines are on a global time, thinking about specifics on ranking with multiple metrics, and just be clear about how things will be aggregated or which metrics are more important. Consider holidays and school schedules. Go through multiple rounds to encourage participation and throughout the submission phase, and recognize not just the top teams, but also first-time participants and other approaches. And then at the end, with the post-challenge analysis, teams submit written descriptions. They test models with their new data sets. We like to bootstrap and look for equivalent methods through resampling of subsets of the validation data, and we use a Bayes factor to find equivalent methods, and typically we'll use the cutoff of 3 based off of this paper on Bayes' recommendations from Cass and Rafferty. And then in the collaboration phase, we will ensemble models and create a meta-analysis of solutions. And so finally, just some more information about DREAM. DREAM is a volunteer network of challenge experts. They can review proposals, offer advice, and provide some challenge oversight. We have our communication channels and a conference, and we have our standardized sets of rules that have been developed over the years that new challenges on Synapse start off with by default. And then just a plug for our platform, synapse.org. It's developed as a data sharing platform, but it's been extended to offer some challenge execution capabilities. So it has the basics, wiki pages, discussion forums, the ability to store files, set up an evaluation queues, and it has its own Docker hub where you can post your Docker there, and then it gets can be privately evaluated, so you're not sharing it outside of the conference, the challenge organizers. We do have a help page on creating and managing a challenge. That's here on the slides I'll share with that will be available after this talk, but that has a step-by-step for creating your own challenges. So finally, some takeaways. Challenges are great to evaluate novel methods, novel data, build community around an event, and provide an opportunity for learning. They are time-consuming to organize, so be sure to plan ahead. And also take care to re-reviews of past challenges, especially some of the references I cited here. There's been a wealth of information in the field about what really makes for a successful challenge that has long-term value. And do consider, existing platforms. You can reach out to me or Grand Challenges to see what it would take to set up your own challenge idea. And so at a couple of minutes over, but I just wanted to see if I can just share the Dream Challenges page. It has a list of all of our past challenges, Synapse itself, and then our guidance for creating and managing a challenge. It has we have our own similar utility libraries in PyPy to set that up, and a lot of code on GitHub to support your challenge execution. So I will stop there, and we can jump into the Q&A.
Thank you so much for the talk. This was also very interesting, also to see a comparison of both platforms. So I see that Bram was already very helpful in answering many questions. We still have some open. So first of all, I think this is also interesting for both talks. Will the slides be available?
Sure.
Perfect. Then I guess we will let you know via Twitter or other media that you can find the slides. So how can information be leaked in the leaderboard? How can organizers prevent this? I don't know who wants to go first. Please jump in.
At a high level, you could think of a challenge as a black box optimization problem. And so if you had unlimited, very quick submissions and a small training set and lots of information on your score, it would be possible to try and just guess and check and optimize and overfit the data. So that's why typically like Kaggle will withhold 3/4 of the data. For our private leaderboard, we can impose some submission limits. That's very common to prevent that.
Yeah, if you search on Google for Kaggle leaderboard climbing, you will find a lot of tips and tricks how you can decode the reference standard if you can submit often. That's of course not the point of a challenge, to hack the leaderboard, but it's a risk that becomes more pronounced when you can earn a lot of money or win a lot of money by winning a challenge.
So do the challenge provide some free storage and computing power, or is it only used to calculate the results using the Docker? I think this was a question for Jake.
Yep. So storage on Synapse is available for registered Synapse users. You do have to. It's a free account. You do have to pass a quiz on data governance. It's like a 15-question quiz so that you understand the rules of Synapse. But yeah, you can you then upload data as you see fit. If it's more than tens of gigabytes, we ask that you sort of reach out to us, or you can connect your own S3 bucket as a Synapse repository. For computing power, we will create our own evaluation node, and and that's a separate EC2 instance that runs to do the evaluation. For model development by the participants, typically they can do that on their own. Many challenges, recent challenges that we've done, we've offered compute credits on TensorFlow Research Cloud, or GCP credits for researchers who request them.
Yeah, and it's similar for Grand Challenge. I mean, we run everything on AWS in the backend. We started by running this on some local computers in our basement, but if the size of the website grows, you can no longer do that on a single computer. So now it's like 200 services on AWS. We have some funding from AWS. We spend some of our own compute on keeping this running, because we are using Grand Challenge a lot internally, like Kieran showed in his presentation. Basically, within PhD projects, we treat a project where you develop an algorithm and write a paper on it as a challenge, basically, because you always want other methods to also be able to apply them on the same data. So in that sense, we can defend that we invest our own funds into this, but there is a limit to that, of course. So if you have plans for challenges with huge amounts of data, or you want to allow algorithms that run 5 days to process a single test case, then we have to limit the cost somehow. And you can contact us and we can see what is possible. The nice thing about running things in the cloud is that you get an excellent overview how expensive everything is. So we can show exactly how expensive every challenge is. And we would like to as a community, try to collaborate on this, maybe get funding for this and collaborate with each other to see that we can do these collaborative efforts and can afford them. I think this is going to be a real issue, right? We all know that the most successful models these days are these gigantic models that are trained on large clusters of GPUs. And yeah, not everybody has these resources available. So we need to be creative and work together to solve these issues.
Definitely. So one question about what are the synergies and differences between your two platforms?
Yeah, a very good point, right? I think Synapse and Sage is broader in scope than Grand Challenge. We started really from image analysis challenges. We are a university group offering this, and we're looking for other university or academic groups to help us with that. But we're also thinking that maybe we should spin out to a separate entity, either for profit or not for profit. I see a lot of similarities with Sage, but also with Kaggle. We worked with Kaggle in the past. I think we should explore how we can work together or be complementary to each other to offer the most services to the research community.
Mm-hmm. Yeah, I agree. So Synapse and Grand Challenges evolved over time for their specific domains, where Grand Challenges is on medical imaging. Synapse was originally created to help researchers share like genomic data or other research data, and they've evolved it into their present forms. But as many groups have recognized the value of challenges, we're facing the same sort of questions about how to take it to another level. There are other open source challenge platforms that are essentially Kaggle clones. You can stand up on your own, like Colab, for example. I think the interests, the capabilities are different. Synapse is built to be like very, very general, like a lot of our challenges. One that we're running now, we have no access to the data. it's stored on a completely separate system, and so those models are moved over and evaluated on that system, and our orchestrator can be run on the on different VPCs. Yeah, I think in the future, expect to see some co-evolution and merging of different capabilities.
All right, we're running a bit out of time. We have 2 questions left. Perhaps we can just do them together. One question is about, are there any data size limits, for example, terabytes per challenge? And what about support of type 2 and 3 challenges in Synapse?
I could do the first one. There are no there are no limits because it's on AWS. So you have to have a pretty big data set that would not fit on AWS, but there are costs associated with it ultimately.
Yes, it's the same. It's S3 buckets. It's unlimited, but if it is, we do have terabytes of data for one challenge that we're working on now. But we want to make sure that is separately billed, and because those at that size, there is not but meaningful storage costs.
And have you thought about things like type 2 and 3 challenges in Synapse?
Yeah, so our Synapse, we've done type 3 challenges where we've done the training and inference. Because the evaluation is still custom coded, we don't have a nice menu of algorithms the way that grandchallenge.org does. We'd like to move in that direction, but currently we code up all of our solutions, and so it's we take the Docker and then issue a train command on some private data, and then do the inference on the validation. So they are both covered with our model to data challenge mode.
I think you did the first type 3 challenge with the Dream Mammography challenge in 2017, right? And,
yes,
that was also, I think, a gigantic effort.
Yes, and that was also terabytes of data, so that was quite a feat to pull off.
Okay, so thanks both of you, or not only both, but the 4 of you, for this super interesting talk. There's one question popping in. Let me quickly check. In the future, how will you ensure that the selected challenge metric actually match the clinical needs in practice? So perhaps, do you have a short answer on this? Of course, not trivial.
Yeah,
I think Anin also tried to answer that, right? I mean, you need to engage with clinicians before you actually launch a challenge. And I think you've also in your papers, Annika, emphasized this, right? You need to make the right choices. And I think the lucky thing about having these systems online is that you can, in fact, later change the metrics and even rerun all the results with a new metric, since both the algorithms and the data and all the results are available in a database on a web platform. But this is, of course, crucially important if you want to have practical impact with a challenge, that you optimize for the right things.
Mm-hmm. Yes, clinical engagement, regulatory engagement. These are very important things. You'll see more broadly, more challenges with these types of interactions. Taking a method and evaluating it not on a static set of data, but real-time clinical data in a electronic health record system. I think that's something that will be happening soon.
Perfect. So we have our questions now. Let's thank our speakers again. And as I said in the beginning, this webinar will also be available on YouTube. So you can also post questions there if you still have any. Thanks for being here to all of the participants, and hope to see you in our next webinar.
Bye-bye.
Bye-bye.